see people joining. Hello, everyone. We wait for probably a couple of minutes just to see, just to get more crowd joining, and then we get started. Awesome. So I'm sure more people are going to join, but I can go ahead and just start with the first couple of the slides where it's more about bio and introduction. And by the time that we get to the agenda, I'm pretty sure more people will be joining. So again, hello everyone. Thank you for attending the second session of our monthly webinar series with the theme of generative AI. In the previous session, we provided an overview of what React agents are. So the React agents, the React stands for reasoning and acting. For those of you that you joined us or you are familiar with these agentic workflows. We showed how to develop a React agent from scratch. And we then briefly demonstrated a simple real-world application where React agents were used to retrieve information from internal and external sources to answer to the user query. In this session, we are going to continue the previous topic, where likewise, in the first half of the session, we will go through fundamental techniques that we use in building large language models. So it's going to be very helpful for those of you that you want to get familiar. And in the second half of the session, Mike is going to take over and he is going to provide detailed walkthrough on the advanced version of the research agents that he briefly talked about in the previous session. So the second half of the session is going to be very advanced and it's going to be very helpful for those of you that you're already into the LLM-based in your LLM-based journey, and that would be pretty helpful for you as well. So before going to the bio, I'm going to provide a brief intro to Arcurve, which is hosting these monthly webinars. Founded in 2006, Arcurve is a full-service technology advisory and software development company. It guides organizations across different industries on their data journey and helping them leverage technology to enable data-driven decision-making capabilities within their organization. So with that, I'm gonna go ahead to the next slide. So as for me, I am working currently at Arcurve as a lead data scientist. And by training, I hold a PhD in civil engineering, which was focused on analysis of subsea pipelines. And I have over 6 years of experience in building machine learning and more recently large language model applications. And by recently, in the past couple of years mainly, and doing simulation engineering and pipeline stress analysis. In my free time, I enjoy playing ping pong, mountain climbing, traveling, and also, as I said before, I really enjoy making and eating sushi. So that's one of my hobbies. Let's go to the second slide. Mike, would you please take over here?
Sure. Yeah, Mike Morley. I'm Director of Machine Learning and Artificial Intelligence at Arcurve. I too have an applied background originally in geological engineering, but got into three-dimensional mine modeling, blast simulation. So spent most of my career working in the sort of joint or location between software, applying software into solving engineering related problems in a number of different industries. I co-founded a company, Menome Technologies, in 2016, which built a system that took complicated data sets, unified them together, and then derived insight from them. I like speaking on the subject of AI because one of the things I do in my role is try to understand the landscape of technology and where it's going, and then help clients understand how they can apply the technology to solve hard problems. And in free time stuff, lots of mountain biking, and I'm really having quite a good time playing music with my daughter, who's a Calgary-based musician. Yeah.
Nice. You're, as I said before, you're one of the most interesting people that I know, Mike. So as for the agenda of this presentation, as I briefly mentioned in the first half of the session, we will discuss some of the fundamentals, concepts, and techniques that we use in building large language model applications. The first one would be the prompt engineering that, especially in the past couple of years, you might have heard a lot about. Then we will talk about retrieval-augmented generation, which is a very popular technique these days. Then we will talk about multi-agentic workflow and evaluation. And in the second half of the session, Mike is going to take over. He's going to talk about GraphRAG, which is a specific kind of retrieval-augmented generation, which is pointed at a graph database instead of a vector database. And then at the end, he's going to basically provide a walkthrough, a very detailed walkthrough of an advanced research agent that he has developed, has been spending, past few months on it. So let's get it started. The intro to prompt engineering. As I said, you have heard a lot about it, about prompt engineering. And in short, at a high level, prompt engineering is what allows us to provide an instruction for the large language model to give us an answer that we're looking for, to basically to be very efficient and to be accurate. So before, we are not going through like different prompt engineering techniques because that requires like a separate webinar. So each one of these techniques that I'm going to talk about, so that alone is going to require a separate webinar. So we're going to just provide a high-level overview and set the stage for the next half so that Mike can take over and you have an idea and you can just do some research about these topics online. There are a lot of good material. So in order to have a good understanding about prompt engineering, you should know that we have three types of prompts typically in an LLM application. So one is the user prompt. User prompt is, simply just a question that's being submitted to a large language model. When you interact with ChatGPT, the question that you ask, that would be stored as the user prompt. Then we have the assistant prompt, which is what's been generated by the large language model to answer to that query. For instance, in this simple example, the user prompt could be explain the concept of regression analysis, and the assistant prompt could be the regression analysis determines the relationship between dependent variable and independent variables. So we have another prompt that's called system prompt. That's what you can also see in ChatGPT. If you go to the setting, there is a place where you can provide certain instructions, and that instructions is what make the large language model pretty useful and pretty customized for our needs. We can provide certain personas, like we can make them to be pipeline engineer or a dentist or a physician or an artist, or we can provide certain instruction on the formatting on the answer that's been generated. We can ask them to provide answer in a bullet point format, and we can also provide some context for the large language model. We can provide information that the LLM doesn't have so that it can better respond to our query. All that are different techniques. Each one of them have a separate term. And so but one important piece in here is that it's not kind of possible that in the first try you get it right. So it's an iterative process. No matter how like advanced your system prompt is going to be, you have to go through it like a try and error. Many times you have to basically edit your system prompt until you get to the point that the answer that's been generated basically passes your criteria. It's like accurate enough, the formatting is right, and everything is based on what you're looking for. So that's a very quick introduction to prompt engineering. Yeah, as I said, like DC is very high level, but it gives you enough information so that you can do an online search for that. But feel free to ask your questions on the chat or on the Q&A, and we'll get to that at the end of the video. So what is the RAG? What is Retrieval-Augmented Generation? I'm pretty sure like most of you have heard about it. So Retrieval-Augmented Generation is a very popular technique these days, and the majority of applications, if not all, they either are built around RAG or they have RAG as a component within the whole system. So what is RAG? RAG is basically introduced in order to solve some of the problems with large language models, things like hallucination, and also to provide a security for the application that's been built at the enterprise level, because there are times that we don't want to use the black box. We don't want the large language model to answer to the question. We want the large language model only be used to retrieve information from our documents. Instead of using its own training data, we wanted to use our documents, our knowledge report, our SharePoint, in order to retrieve information and answer to our query. That's where RAG would be very useful. And you can build the whole thing within your cloud environment so that no information goes out from the cloud. For instance, you can build it within Azure. Even if you don't want to use some of the models that's been hosted by Azure, you can build your own open source, and you can basically like develop or deploy enough resources for that you can run the inference against your local, so effectively your open source large language model. This way, you don't need even to do an API call and send data even outside the cloud environment, which is in most cases okay if you want to just do an API call, because most companies, pretty much all companies, when you do API call, they don't train over your data. But anyway, so RAG is a very popular technique. There are 4 steps in building a RAG application. One is the indexing. Indexing is where we transform the document. Let's say that you have a manual, which is 100 page, and you need to transform that into a format that's retrievable by the RAG system. And by that, for instance, in easy basically form, if I want to explain that, your 100-page document should be converted into 100 text chunks. And each one of those text chunks should have a vector associated with them that contains the semantic meaning of that text chunk. And that's going to be used later on when you want to ask a question and you want to retrieve relevant information. Because your question could also be transformed into a vector, and then you can do a vector search and find the most similar vectors from those 100 or 200 text chunks that you have from your document. But this is not just about one document. You can have all your documents within your knowledge repo to be transformed, and you can run your query against all your indices. So that's basically the first step. And yeah, there are so much details. For instance, even in terms of the chunking, there are different chunking strategies which make the RAG system more accurate. And one of the areas that Mike is going to go over and talk about is about his specific chunking strategy that he has leveraged in the research agent. So he's going to talk about that. And then we have the retrieval. Retrieval is where, based on the query that's been submitted, we transform the query into a vector. And for instance, if the RAG system only uses the vector search and it doesn't uses like in-text search, any other techniques, it does the vector search and retrieve relevant chunks of text from the document or from the documents. And then we have the third step, which is synthesis. And in this step, the large language model will be fed by the original query or the extracted semantic meaning of the query. So, I mean, there are some additional steps here, but these are the core steps. So the large language model will be fed by the initial query and the retrieved text chunks. And then LLM will use all the context that's been provided in addition to the query, and then it provides a coherent answer to the original query. But all good. How do we understand if it is accurate, if it's useful? So that's why without an evaluation pipeline, it's not very useful. I mean, we cannot use that at the production level, at the enterprise level. So we need to have like different evaluation metrics, and we need to constantly monitor that just to make sure, even if the LLM application is doing a good job now, does it do a good job over time, or does it deviate from the thresholds that we have defined? That's why evaluation is a very important piece of the RAG application. We will talk about evaluation a little bit more in the next slide. So as for evaluation, there are many techniques and many like metrics that we can use. I'm going just to go over like a few of them. So one of the things that we typically do in the projects is that we ask the client or the subject matter expert, a person who knows the documents. Let's say that if it's a manual, that it's like 300 pages, and there's a person who has been using this manual for about 10 years. He's a subject matter expert and he knows the manual. And he needs to just put together a test set. And by test set, he has to put together, like, let's say 100, 200 questions and the answer that he is looking for, that the large language model has to provide in a format that he likes. So that would be a test set. And then what we can do, we can basically use the test set and we can pass or feed the questions into the large language model and compare the LLM generated answer against the answer that's been basically provided by the SME, by the subject matter expert. And that would be like one test that we always do. And the second one is manual labeling. So although we do the test set, but we also want that once that we have delivered the large language, the LLM-based application, or it's at the test stage, we want the client or the subject matter expert to start asking the question. And based on the answer that's been generated, they can thumbs up or thumbs down. And this way, we can also monitor like in the period of like 2 months, 3 months, 6 months, how many times it has got it wrong. For instance, we can say that our threshold is 98%. So if 2% of the time the answer was not desirable, that's fine. So like any other system or any even like us, it can also get it wrong, but we should have a threshold and we should basically define what we call success, and we should define what's the threshold that our company is comfortable with. And then we have evaluation metrics. So these evaluation metrics is specific more toward the RAG application, but we can define based on the use case what like metrics we're looking for. For instance, in RAG application, we typically have a relevance metrics where the relevance of the LLM generated response is compared against the original query, just to make sure that is it relevant or it's like something else. And we have groundedness. We want to make sure what's been retrieved also aligns with the query, not just the last step, which is the LLM generated response, but also the retrieved contents from the document. We want to make sure that they also align with the original query, so that we can also test our retrieval pipeline. And then coherence is that we want to make sure the system prompt that's been used for the LLM also, does it do a good job? Does the answer, like, is it in the correct format? Is it also coherent? So these are basically 3 main steps that we typically go through when we are building a large language model applications. So there are like, I think, couple more basically fundamental concept that we want to go through, and then we can switch to the agent, the research agent that Mike is going to talk about. The other fundamental concept that's quite important is function calling, and that's in concept pretty simple. It effectively means that the large language model should map the query or the question to a particular tool that we have already defined for the model. Let's say that we have a bunch of tools, and those tools could be like Python functions, and they do math, or they do they provide a specific information, or that one of those tools could be a RAG. So we can provide description for each one of those tools, and we can also introduce those tools within the system prompt to the large language model. And when you ask a question, the large language model can map or can connect your query, or if your query is pretty complex, your subqueries, each one of the subquery, to a specific tool from the toolbox that you have defined. So that's one of the very important functionality that most modern LLMs have. And this is basically like a quick visualization, like a very brief visualization, that when the user query has been like basically broken down into smaller pieces, if it's pretty complex, then LLM could be used to map each one of these subqueries to a proper tool. And finally, as the last slide for providing the fundamental concept, and basically just set the stage for Mike, we talk about the multi-agentic workflow. You already got some idea about how to make an AI agent. So AI agent is nothing more than a large language model with a specific and unique instruction. So let's say that you, in your system prompt, you provide a persona for your LLM to be a pipeline engineer, and you provide a bunch of tools for your pipeline engineers, and you provide some instruction on how it has to go about answering the problem. And you also provide some context, some information from a certain manual or a design guideline. So all that will turn your large language model into a unique basically agent that you can leverage within your system. But you're not limited to create only one agent. You can create as many agents as you want. For instance, let's say that if you want to write an article, so that article might require different expertise. Maybe like it is an interdisciplinary subject where we need someone from civil engineering, we need someone from electrical engineering, someone from computer science. And you can define 3 agents, and you can make them to work either in parallel or sequentially. Once one of them is done, the other one take over and just start and add some contents. That's why the idea of the graph is quite important, where each one of these agents could be a node, and those nodes could work either in parallel or sequentially to basically reach to the object that you define for them. So with that introduction, I'm going to pass it over to you, Mike. So please take it over and go ahead.
Excellent, thanks. Yeah, so we're going to investigate some of the concepts that Farhad was describing by using the personal knowledge vault that I've been working on for the past while. And what the objective of this particular system is designed to do is to leverage some of these AI technologies that have been coming out to help a person that I know with some functional memory challenges write their memoirs. So that's kind of the top level objective. One of the things they need to do in the context of writing their memoirs is research various subjects that they may remember from, the work that they did and events that happened and whatnot. So a person in this sort of situation can have some trouble necessarily using various search tools and all these kinds of things, particularly more complex systems like SharePoint and whatnot. So what this agent, the objective of this particular agent is to extend the paradigm that we looked at last time, which was a simple agentic chat agent that searched kind of inside the repository and outside. We're going to build on the basis of that, but by extending it into this world of LangGraph. And in this case, what's going to happen is the person, the user is going to be able to provide the research agent a topic or a series of topics. The agent will take those topics and it will go out and scan through the internal sources and scan, in this case, one external source, but you could add more, and I will be adding more to that over time. But it will then gather up a number of articles that match the topic intent, and then generate a written synopsis of the material that it collects as an output, and then provide that back to the user. I'll go through this in more detail, but at a high level, we're going to be using ChatGPT, GTP as the interaction layer. So this is now with, as of yesterday, OpenAI has now released its full conversational interface on mobile devices and whatnot. So it then becomes possible to have these interactions just using words and speaking to the thing, which is pretty powerful. We're going to be using LangChain through Python Fast API as the API layer for this. And we're going to be, of course, using a Neo4j graph database as the knowledge store, which the interesting thing about the fact that we're using LangGraph is because it's a graph structure, we can also store the entire workflow chain into the graph database and have everything that the agents did through the context of the workflow stored and captured, so that we can actually see and understand all the steps that it took. So it's quite a powerful paradigm. So last time, just to set the context a bit, we looked at the basic agentic chat. And this is what we would call a fully autonomous agent, in that it's using basically a single prompt to govern the behavior of the agent itself. And in this case, we had a series of 4 tools that the agent had access to. And we conditioned that agent in such a way to say, you're going to answer a question using these tools. This is the prompt that you see here on this side of the screen. You're going to go through the action, thought, action, input, question, thought, action input, observation steps, and then final answer output. These agents are a little easier to set up in terms of the amount of code that's required, but as Farhad indicated, the tricky bit is the prompt and evaluating this type of a prompt. So this works okay if you've got a fairly simple workflow case, which this was. We're asking a question, we've got a couple of tools that are only connected to a few sources, and then we're getting an answer back. If we get into something that's a lot more sophisticated, like the types of things that you see typically in the enterprise, like even something like an expense approval process, would be beyond the ability of a simple agent, fully autonomous agent like this to handle, because there are the rules become very difficult to test. There's so many permutations and combinations, a lot more tools. We can't rely fully on a probabilistic agent to make the correct decisions working through a complex path like that. So what we do is we blend in the idea that Farhad was describing, this notion of a graph, a workflow graph structure. So we use the idea of some deterministic steps that map out the way we want this workflow to proceed. And then what we do is each node in the step can be considered to be an individual agent that is then connected together with relationships in a chain designed to accomplish the objective. And what this does is it's almost like putting a train on train tracks. You then can have stations along the train where there may be switches that allow decisions to be made about which direction the workflow should proceed. And what we do in this case is, so one of the things that tends to be pretty tricky in the context of writing these workflows, this idea has been around for a while, but in enterprise software, the rules that are required to manage these things can get to be pretty complicated very quickly at these decision points. Even something simple like an expense approval. What happens if the expense is above a certain threshold? That has to go to somebody who has to approve it. If that person's away, who's their backup? The rules get exponential in terms of complexity very, very quickly. So what you can do is now with these large language models, we can introduce these sort of agentic decision points into this graph structure, workflow graph structure, so that the areas where we need a bit more flexibility, so we don't have to define every single rule that exists. We just have to have the large language model conditioned so it can make a decision within a context. What that allows us to do is we can take advantage of the power of the large language model to augment these workflows, while also still making it possible to program them, make them reliable and effective, and be able to evaluate them. Behind the scenes, as Farhad was describing, so in the case of this particular system, I'm using a graph database, Neo4j. And there's a few reasons that I chose to use it for this. You could use a vector database for this type of workflow as well. The LangGraph and LangChain do support vector databases. The nice thing about the graph, though, is it does give you a lot more flexibility and optionality in terms of the way you set up the retrieval processes and the way you can also work with these types of agentic workflows and whatnot. So the objective here, as Farhad had described, is we want to take unstructured data and we want to render it into a form that is more like structured data, that makes it amenable to working with agents and have the agents interact with the system. So in the case of this particular system, what I'm doing is I'm taking, so this is also pretty cool. And this is another thing that I get really excited about the world of large language models for. The thing that you see on the left is a test that I did. Because one of the things that's been really hard is trying to capture data from the field, observations and whatnot, you know, tablets, forms, all these things, really complicated to set up, difficult to use. Well, with the Omni model, it's come out from ChatGPT recently, or GTP, sorry, OpenAI. It can actually recognize handwriting very effectively. So this handwritten thing over here that you see is in my terrible handwriting is an example of a field observation you do looking at a well site. And you drop that into OpenAI, into ChatGPT, and then I have an agent that grabs that and decomposes that down into the structure you see here, this graph document structure. And it does it with an incredible degree of accuracy. If you look at the text that's on the right, assuming you can read my handwriting, OpenAI, the agent can't, which is amazing. But the structure itself is interesting because what we do is we take we create a document node that represents the actual artifact that's coming in. Then what happens is I'm doing a basic semantic decomposition. In this case, there are other patterns you could apply to this that, depending on the way you want to structure your data, that could be more amenable to the type of information coming in. But we break this down into pages, and then we break the pages down into semantically relevant chunks, essentially sentences in this case. So what that lets us do is it gives us some optionality in terms of targeting the vector indexes for chunk retrieval. And as we showed last time, I set up two indices in here, two vector indexes, one that was targeting the page level nodes, so much larger chunks of information, and one that was targeting the child level nodes. So these are the semantically decomposed sentence chunks. So then what ends up happening is when we're setting up the chat agent, or we're setting up the research agent in this case, we have a number of different strategies that we can use depending on the type of question the user is asking or the type of request the user is asking. We can have our agent decide, okay, this is a very specific question, so we're going to try and slice it, direct it into the smaller chunks to get more accuracy in terms of bringing back chunks that are specifically relevant to the question the person's asking. Or if we've got a more broad question, we can hit the page level, which then does a much broader retrieval and answers a much broader range question more effectively. There's lots of other strategies that can come out of this graph as well, and we'll be talking about some of those in later sessions. You can kind of see on the right, on this side here around the document node, I've also now got a system that is generating categories out of the text that comes back from the nodes. This then also provides the ability to cluster and create communities, and gives yet another strategy for retrieving information and targeting questions and answering complex multi-level questions as well. That's for a later session, so you have to stay tuned for that. Specifically with the research agent, as I mentioned, the other thing that's pretty impressive about the combination of LangGraph and Neo4j in this case is that you can also capture the workflow that the node went through, that the agent went through to get to the resulting output. So the output you see on this side of the structure here, this is the research that's been compiled. The request that came in was asking about OpenAI 01 model capabilities. So that was the topic that was being researched. Each one of these green nodes corresponds to a specific agent inside that I'll show you in a second in the code in the Python side of things in LangGraph. So it's a one-to-one match with these things. And the nice thing about that then is I can actually capture the outputs of the step. So what you see here is the curate node is connected to the external search nodes and the internal pages that the search node had picked up, and specifically the ones that the curate node agent selected for then providing to the writer and so on. But I'll go through this in some more detail in a second here. Suffice to say that this is the graph that is produced and stored. And what this does is this also allows us to view and understand what the agent is doing in the context of evaluating how effective the thing is working, which is important. So getting into the demo side of things. This is, of course, an initial proof of concept still. I will be publishing this code for nodes coming up. We're doing a session on this whole system at the Neo4j event that's coming up in November, so stay tuned for that. The code that you see here will be published along in context of that event. And let's get into the crux of the biscuit. All right, so the research agent. There are a number of agents that make this up. So this is a multi-agent workflow in which a number of agents are collaborating together to create the output. And what we do is we start off with the search agent. The search agent has two tools, an internal search and an external search that we used, same sort of pattern we used last time. So the internal tool goes after, search goes after the documents that are currently stored in the graph. The external one goes out to Tavily. Right now, you could add additional search tools into this, and likely I will as I move this thing along. The search agent's job is to collect 10 articles from each source that correspond to the topic. Then what ends up happening is it passes that off to a curator agent. And this agent's conditioned through a prompt to filter and select articles based on their relevance to the topic at hand. So it cuts that back to 5 articles, or the top 5 articles. Sometimes it actually selects less than that if it feels the articles aren't specifically relevant to the topic at hand. And then it passes those on to a writer agent. And this writer agent's pretty cool because it's actually got a 2-piece agent. There's 2 personas inside of this agent. One is a writer that's prompted in a specific way to then write an initial article using the sources provided. And it's connected to an editor article. So these are an editor agent. And these 2 guys work in parallel to then construct an article output from the sources provided. Now, in any kind of research thing, you want to have an external critique. You usually send out articles out, if you write one for a scientific paper or otherwise, to critics to review. So created a critique agent that does this. And it's conditioned to act as a critic who's an expert in the field of the topic. It will look at the incoming article and provide directed feedback. If the feedback is provided, there's a branch. So this is another important concept in the context of LangGraph, is you can have conditional edges along the workflow process. And these edges can be set up in such a way that if certain conditions are met, you can send and direct the workflow down different paths. So in this case, we've got a loop that goes back. So if the critic goes, yeah, this is pretty good, but these are some other things you should do to this article to make it better, it'll fire that back to the writer agent, which will then pick the thing up, modify it, and send it back to the critic. You can set that process loop to operate on a certain number of times to restrict it from running indefinitely. And there's other kind of control mechanisms you can have in place that help this make sure this processes operate within the bounds that the developer is setting up to meet the business rules. Once that passes, once the critic has no more feedback, that's passed over to a designer agent, which right now is a very, very basic thing. It basically formats the incoming text into a markdown structure. Farhad had a really great suggestion for it, though, that I'm pretty keen to implement, which is taking the text of the article and then firing that into DALL-E to get it to generate a custom image for the article. So that's on my to-do list, which is pretty cool. And then that goes to the publisher agent, which takes all of the information that's come through, and then it stores that and the workflow and everything else into the Neo4j graph database. All right, let's have a look at some code here. So what I'm going to do is we'll zoom this up a little bit and put this over on the right-hand side. This will take me 1 second to get set up here, just so you can see what's going on. Guys there, and we'll bring up our code. There we go. All right. So on this side of the screen, here is our agent structure. And this side of the screen, you see the actual source code for this. And what you'll notice, of course, is that this looks exactly like the graph structure, as it should. So we start off with our search agent, and let's have a quick look at our search agent here. So as you can see, the search agent basically has, is just set up in a very, very simple way in this case. Oops, it has two tools in it that are the same as the tools that we used in the last session. One that goes out to Tably and asks basically to get the topics, the information for the topics with max result 10. So get 10 articles from this particular search source. And then it has a second tool in it that goes after, that runs a search on the internal database using the query, basically the topic query that runs against the child index to get the details chunks back. These sources are then assembled and they are passed on to the curator agent. Now the curator agent gets to be a little more interesting because this particular agent then has a prompt condition in it. And the prompt in this case, and you can see here, there's two parts to one of these sorts of prompts typically, and there can be a third now. They've introduced this idea of strict outputs, which is really handy. So instead of doing sort of this type of conditioning here, you can actually move this directive into a new structure that allows you to actually dictate to the large language model exactly how the output should look, which increases the reliability of these things. I haven't implemented that yet, but it is on my to-do list. The two parts are, you are a world-class expert research in the domain of the given topic. Your task is to critically evaluate and select 5 most relevant and high-quality sources from the list of articles. Use your expertise to assess the credibility, relevance, and scientific merit of each source in relation to the topic at hand. So, as Farhad mentioned, these prompts take some work to tune. And it did take me a bit to get this to the spot where I was seeing the outputs kind of resonating with what I was trying to accomplish with this. And it's the kind of thing where, depending on your user and your use case, you may have to shift the intent here. Instead of a researcher, this may, you may want this to be an author in a certain domain. The terms here matter in terms of the way these agents will react. In this case, once I ran the evaluations on it, it seemed to be working quite well for what I was trying to accomplish. So once we get through that guy and it's picked out the articles that it feels are good for the topic, it'll drop into the designer, the curator, or the writer. That's what I wanted to get to. Sorry, there we go. And again, you'll see the same pattern here. We're basically conditioning the writer to take the inputs that the curator has given it, and it's being conditioned to be an expert in the field, again, of this particular topic. And its job is to write a meaningful article using the references given. The additional thing that we've done in here too is we've also got this editor co-agent that basically its goal is to do an initial critical review to enhance the article, ensuring it meets the highest academic and professional standards, etc. So the idea with this is these two agents, it's actually kind of fun to see this kind of bounce back and forth, but they will bounce things back and forth depending on the number of retries you set. In this case, I've just set it to 1 for the sake of expedience, but you can have this run a number of times, and you can kind of watch it revise the article as it goes, which is neat. Once it gets through that step, then it passes to the critique agent. And again, this one's kind of interesting in that this is an external reviewer. You're an expert in the subject of the article. Your sole purpose is to provide short feedback on the article that's written by a student in the subject of the domain. So then we're telling this thing that we're conditioning it specifically to suggest that the writer is not at the same level of expertise necessarily as this critic is. And that's deliberate so that it will provide feedback on the article coming in. The other trick with this is you'll notice that there's conditioning in the response. If you see the field message in the article, it means there's revisions. If nothing kind of comes back, you can provide feedback, or if this critic feels it's okay, it will say none. And then what that does is the conditional logic coming out of the branch, if it sees none, it will then pass through to the next stage, which is the designer. The designer, as I mentioned, is currently very simple. Its job is just to take the text and format it into this markdown structure. And then that goes out to the publisher. which in this case is conditioned. There's no conditioning here specifically. It's just an agent that writes stuff into the graph database. Okay. So, and then putting that all together, looks like this. You'll notice here that each of these agents is added as a node in the workflow graph in sequence. We add an edge, and these are directed edges in these cases. You'll notice there's no conditions on the search to curate to write to critique. But on the critique, we have a conditional branch where accept, so pass through if there's no, if the result is none, otherwise send back for revision, which sends it back to the writer. Okay, let's have a look at this thing running it. So we'll bring up our monitoring window, and we'll bring up our ChatGPT thing. And actually, I need to get demo text. Oops. So we're going to research this topic. Here we go. Get rid of this little thing so it doesn't mess it up. Now, fire that off. What should happen if life is good in demo land is we should see this starting in action. The action should be research topic. If I confirm this, it will pass through and we should start to see things happening on this side. There we go. We see the token pass for authentication. We're seeing the agent trigger its request to start to search things. And now what we should see is if we hop over to our graph, just check to make sure that that prompt came through. Yep. Okay, topic, that's this. Grab the topic. And let's get our LangGraph guy up here. The topic in this. And now let's have a look at the graph structure. Ooh, and you see all kinds of stuff happening on the one side here. This is now, it's now finished the primary research, and now it's triggered adjacent downstream processes that are actually constructing, breaking out the pages, decomposing the document down, and a whole bunch of other, and generating categories. What we should see on this side is the agent will then respond to the user in ChatGPT. This can actually now, with the new one, actually be read back to the person, which is really nice. It'll provide an overview of the article, the link to the full document that's been produced, and then also the sources that it brought in from the external search. Now, what we do is if we'll go into the graph here, let's have a look at this more closely. Hopefully you can see that okay. This is the backbone of the graph. Let's just orient this the right way around. So what you'll notice is this is the starting node that came in. This has the topic on it that you can see over there, impact of agentic AI on enterprise software. And then what you see as we go through this, there's the search. The curator then is showing us the articles that it pulled in. So we know exactly which articles were pulled in with this. You'll notice now as the graph starts to evolve, as that process runs in the background, what that's doing is that's decomposing these documents down into the graph structure, adding them to the vector index, and building this out so that these articles then become searchable. And you'll notice that this article hasn't been processed yet, but as I continue to speak, you'll see more and more of the graph get built out because this all runs asynchronously in the background. What we should see on the critique agent is we should see 2 passes because I limited it just to single pass back. But on the critique, the critic provided some feedback, and the article provides a comprehensive review of the potential impact of agentic AI on software. However, it could benefit from more concrete examples and case studies to illustrate how agentic AI is currently being used in the enterprise. Additionally, the article could elaborate further on practical steps for the organization, etc. So it did provide some feedback on the article itself. And now what we should see is at this end of the chain, we should get our full markdown output, which is here. Let's just grab that. And we'll drop that back in our editor. Demo, there you are. Save that, and let's preview this. So here we go. So this is the output from the research as it collated all this information together and put that, collated this, put this into this context. It's highlighting, I won't read it in detail. I can provide this to folks if they want to read it later, but it basically has done that from synthesizing all of these sources. So the nice thing is for the person looking at this on the other side, they can use that as a synopsis summary of the information that was given, and then they can go back and drill into the sources that are all detailed in here. You'll notice as well that our curator guy, it's picking up these are referenced from existing sources internally that are already in our knowledge repository. If I keep expanding this out, you can then start to see how this graph is built up, where you've got the pages are linked to other sources. This node where the document has been written, I can link that to it was sourced from this. So this is the other area where the graph becomes extremely powerful, is I know exactly what sources that article was written from. And I can have that articulated and specifically defined in the graph. So I know as the user of this thing, if I want to dig into this and know exactly where all the information that's come out the other side of this comes from, it's all right there. And now as this thing runs, let's bring back this topic with all of it. The other thing that we're doing to set us up for our next, or one of our future sessions, is the fact that we are also now generating categories to further contextualize the graph in behind the scenes. This will take a second. Also a good time to probably start pausing for questions as this renders itself. So this is the whole graph. Now you're starting to see it become more filled in. You'll notice all the document nodes now have page nodes, child nodes. I'm also generating additional questions for lines of inquiry and whatnot. And then you'll see, in addition to that, we're now starting to see categories emerging out of the graph as well, out of the documents that were pulled as well. And the interesting thing about the categories is this will eventually be used to provide further context for the knowledge base in terms of community clustering and other sorts of things that give us the ability to increase the sophistication of the GraphRAG retrievals and whatnot. Again, I'm not going to go into the details of that now, but suffice to say, stay tuned for more. So, questions, sorry.
Great. Thank you very much, Mike. That was fantastic. So I see many applications for that. I mean, for instance, I have written a few research papers, and I know in the research paper it's pretty easy. The methodology and the results section are pretty easy because that's what you have done. But our introduction, conclusion, and basically summary, that basically takes a while to get it right. So you can just turn it into this agentic workflow, and they do the research for you, and they come up with the best section for you just to overview. And there are also other applications for a person who wants to write a report only against the internal like knowledge repository. They can also write the report using this agentic workflow. I see so many applications for that, and yeah, this is very exciting. So we have we have a few minutes left. For you guys, if you have any questions, please put that on the chat or on the Q&A, and yeah, we can answer those questions. And also for the next session, we are going to discuss one of the very interesting and innovative application of these agentic workflow in pipeline industry. This is a topic that's been presented at the International Pipeline Conference, and it's very exciting and it's very interesting. We will hopefully cover that sometime in October, and just stay tuned for the post that's coming on LinkedIn, and make sure that you follow Arcurve to get the notification.
And that one's a really nice one. This example you see here, of course, is a general example that's corresponding to researching documents, topics, things like that. The one that Farhad's going to speak about gets into actually applying this to an engineering use case specifically, and it's pretty impressive stuff. So I'm looking forward to seeing that. I'm mean, I'm familiar with the work already, but I'm looking forward to seeing it kind of live.
Thank you. So thank you, Chris. Yeah, appreciate the compliment. And I see like people are typing, so we can stick around for a few more minutes if there's any question. So I got one question from Benjamin. How does this work with consecutive queries? How does this work with consecutive queries? I could see the graph exploding in size fairly quickly.
Great question.
That's for you, Mike.
Yeah, so you're absolutely right. But the neat thing, and again, this gets into the way that this is structured, the ways that the graph works as well. I've got a system in here now, and I didn't have it originally. So there's a couple things that play into this. One is the fact that when you do operations, and I actually ran this morning and saw this actually happen. If I run the same topic twice, what tends to happen is if it starts to bring in the same documents, and what I'm doing is I'm merging the documents that come in based on their URL. So this is a unique reference to the article itself. The way the merge operations work in Neo4j, it's pretty sophisticated, and you can condition the way the merges happen. So in this case, the thing is set up to, if that document already exists, it will just land that document on top of the same nodes. The nodes will just merge together. So what ends up happening is you can converge there's a natural convergence that happens if the same types of information start to come in. That's, of course, not always the case. And you will get situations where documents that come in may be similar, but not exactly the same. And this is kind of a look a little bit at the, see if I can zoom this up a bit here, at some of the, there's about 2,600 articles and documents in here so far. Every time I read something, I add it into this thing. So this process is running constantly. What I did do, and I've just added that in recently based on some work that Tomasz Bertanek did, which is pretty great stuff. He created a structure for a deduplication similarity system. And again, this is also where the Neo4j thing is pretty nice because what you can do with it is it's got a whole pile of graph algorithms built into it. And then using some of the similarity functions that exist, you can have a strategy set up for doing similarity comparisons, which then allows you to connect up nodes that are similar, resolve nodes that are similar, and come up with ways of potentially rectifying things. So if you get two documents that are basically the same version, that are close and are technically actually the same thing, there's a bunch of ways you can use, where is it here? It's a multi-level stage thing. It actually may be worth doing a session on this because it gets into there's a bunch of elements to it. Essentially, at a really high level, though, the way it works is I construct. Actually, they got the instructions up here. I'll show you that. Here we go. Rules. Entities with minor typographical differences should be considered duplicates. Entities with different formats but the same content should be duplicates. Entities referring to the same real-world object or concept, even if described differently, should be duplicates. If it refers to different numbers, dates, or products, don't merge. So this thing, the way this is set up, is it uses some community detection algorithms and similarity algorithms that work at the text node level. And it sort of steps up from that. And then eventually it goes into actually using a large language model to provide a percent similarity between key aspects of two nodes. And then I can decide whether to link them or to merge them. Sorry, that was a long answer to that.
Oh, that was great. Thank you, Mike. So there's a follow-up question on that. That would be super useful. Is this part published as well?
Yeah, my plan is to publish this code base coming up for the nodes event in November. So it'll kind of be part of the stuff we're doing is in context of these Arcurve webinars. I have a bit of cleanup work to do with it, so that's why I gave myself a deadline. Yeah. Otherwise, they just keep adding stuff to it.
Yeah, nice. I think we are right on time. I can see no more specific questions. So thank you very much, everyone. I really appreciate attending this, and stay tuned for the next webinar. Thank you.
Thanks, everybody. Appreciate you
Thanks.
hanging out with us.
Thanks. Bye.